Okay, we're going to talk about some more about areas. This time we're talking about areas of regular polygons and circles. And let's take the regular polygons first. First of all, let's remind ourselves what a regular polygon is. A regular polygon is a polygon that has congruent sides and congruent interior angles. That means it's all of its sides are the same length and its interior angles are the same measurement. Okay? That's nothing new to us. We've been dealing with that for quite some time. Now here's a term you might not have heard or you need to be refreshed on. I think we took care of it and we talked about this on quadrilaterals, regular quadrilaterals, and dealing with those, and on circles. But the apothegm is, this is apothegm. No, it's not a possum with a lisp, it's just apothegm. A line segment drawn from the center of a regular polygon perpendicular to one of the sides. Okay? Now let's identify this thing. Okay? Perpendicular to one of the sides. And I'm going to call it little a. And in this equation we have the area is equal to 1/2 capital P times small a. Or the area is equal to capital P little a divided by 2. Pick which one you like and go from there. Where capital P stands for the perimeter of the regular polygon and A stands for the apothegm. Okay, and the apothegm is this piece right here from the center of, right there, the center of the regular polygon to one of its sides and perpendicular to that side. Over here, regular pentagon from the center to one of the sides, perpendicular to that side. Now, what that's going to do is that's going to act as a altitude for a triangle drawn. Okay, we see this triangle where we have a segment drawn from that center, that same point, to the vertices. This is going to act like an altitude to that. Now, that's an isosceles triangle. So this is going to cut this side in half. Same thing over here. This is a characteristic of an apothegm of a regular polygon. It's going to cut those triangles in half. If we were to draw those, why? Because we've got 5 congruent triangles here. We've got 3 congruent triangles there. Why? Because we have regular polygons. Okay? So let's look at this and talk about how we do this. We've got one of these sides is 14. Okay? 14 meters. So what we can do is we look at this and we go like, okay, we know that this angle right here is 160. We know it's 60. We know this is 120. Well, if this is 120, then this part of it is 60. If the whole thing there is 60, we know this piece of it is, what, 30 degrees. So that's a 30, 60, 90. If this is 14, we're going to cut this side in half. That makes this 7. What's the short side? The side across from the 30? Well, it's the longer leg divided by the square root of 3. So we've got 7 divided by the square root of 3. What's the hypotenuse? Double that. So that would be 14 divided by root 3. Okay? But we need to find the apothegm, which is the 7 divided by the square root of 3. So our equation is, I'm going to use this one, is 3 times 14. Okay? Let's clear this up a little bit. This is a multiplication. 3 times 14. Okay, why that? Well, that's P. 3, we got 3 sides that are 14 long, so that's going to be our perimeter. And then our apothegm is 7 divided by square root of 3. And then we divide all of that by 2. Well, 3 times 14 is 42. We still have our 7 divided by square root of 3. Okay? And we still have our 2. And when we do this arithmetic, we should get 84.87, close to, meters squared. Okay? Here's our apothegm. This is our perimeter. Okay, let's look at a regular pentagon and do the same thing with it. We have a regular pentagon. We're told that it has a side of 10 inches. Okay, on a regular pentagon, its interior angle is going to be 108 degrees. Well, and its central angle is going to be 72 degrees. Well, how do I get 72 degrees? Well, I go around once, I go 360. 360 divided by 5, because there's 1, 2, 3, 4, 5 of those, I get 72. Well, that central angle is 72. Then when I drop this apothem down from the center of that regular pentagon to one of its sides perpendicular to it, I'm going to cut this angle in half. Why? Because this is an isosceles triangle. Okay? I'm going to cut that angle in half. So this is 36, 36. Now, this right here, 36, subtract that from 90, I get 54. Or 72, subtract from 180, I get 108. And this is an isosceles triangle, so this angle here is 54 degrees. Well, if this whole side is 10, then I know that half of it is 5. Okay? So half of it's 5. So we need to find the apothem. Well, I'm going to take the approach from standing here, and I'm going to use the tangent of 54 degrees is the opposite, which is my apothem, divided by my adjacent, which is 5. So A, my apothem equals 5 times the tangent of 54, which rounds to about 6.88. What's my perimeter? Well, I've got how many sides? 1, 2, 3, 4, 5 of them. They're each 10 long, so what's my total perimeter? 50. So my equation, 50 times 6.88 divided by 2, and when I do that, I should get 172.05 inches squared, because their dimension is in inches. Now, let's look at this, and let me tell you about one of the things that will happen. A lot of times what will happen is they'll put this baby into a circle. It's not a very good circle. And what you see right here is this right here, this hypotenuse of this triangle here, these hypotenuses will be the what? They'll be the radius of that circle. Alright? So, one of the things that will happen is you'll have to find the area of the circle given the regular polygon, in that case a regular triangle. And in this case you'll have like, okay, almost did it, didn't quite. But again, this right here, or this hypotenuse right here of this triangle that you've got right here, will be the radius of that circle. Okay? That's a very common problem to put in there, and then ask you to find the area of the circle. Okay? So what you have to do, given that this is a regular polygon, then you've got to divide that thing up into triangles and do this, find the area of this, and then find this side. Okay? Which is not hard to do. It's the hypotenuse of that. You can use it to find that using the sine or the cosine. Okay? But there's a lot of problems. Now, there's nothing new in doing this. We know how to do all of it. You know how to use trigonometric ratios. You know how to find these angles. Okay? You've just got to remember how to do that. And you know how to find the area of a circle. This is R right here. You just got to know that that's R. This is R. Okay? You just got to remember that that's R and find that. Okay? So that's how we find the area of a regular polygon, and that's also our sample problems.